Now we will be reviewing the final 2 pages of your Unit 7 review packet. So the first problem on this page says, what is the distance between the 2 points? -6, 9 and -6, -5. So you can see that they have the same x coordinate of -6. However, their y's are different. 9 is positive, it's way up here. -5 is negative, way down here. So how far apart are they? Well, it's pretty easy to find when they share a coordinate. So they share the x coordinate, like we said. They both have -6. So then all we have to do is count down. So we can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. They are 14 units apart. Okay. So, and once again, if you did 9 minus 14, that would get you to -5, their y coordinate. So you can always just, if you are given the graph, you can always just count the spaces. Now for number 3, this should look familiar. We did use this graph on an activity before. So the graph shows the balance in a bank account over a period of 14 days. The axis labeled B represents the account balance in dollars. So everything up and down is the amount of dollars in the account. And the axis labeled D represents the day. So that's important. D is day and B is account balance. So what was the balance on day 2? So the days are my x axis. So day 2 would be right here. And now I need to find the balance, which is along the y, and I scroll up. And I can see that on day 2, there was $350. Okay. What was the balance on day 6? So once again, days are the x-axis going left to right. Day 1, 2, 3, 4, 5, 6. And the account balance point is actually here, and that's at -50. There was -50. So once again, that's the concept of being in debt. So in life, you can have negative money. That means you are in debt. You owe more money than you have. That's when we would represent money as negative. So on what day was the balance the greatest? So I can already automatically ignore the negatives because negatives are small. That's debt. So that's definitely not going to be the greatest. And I'm looking, and it looks like this point is the highest. And that's on day 14. On day 14, it was the greatest. And it looks like it was, so here's 350, here's 400. It looks like maybe it's like a little bit more than halfway. So halfway would be about 375. I'm going to say about $380. And remember, this little squiggly equal sign represents like an estimate. It means about equal to. So if it's totally straight across, that means it is this and nothing but this. This little symbol means about. All right, and our final page. So first we were talking about the GCF. So I'm just going to define these terms real quick. So the GCF is the largest factor both numbers can be divided by evenly. So the largest number that both can be divided by without making a decimal or a fraction. That would make a whole number. So a really common way to find the GCF is to write both of your numbers and then write all of the factor pairs. So I always think it's best to start with 1 times that number. That's a really easy factor pair. Every single number in the universe is divisible by 1 and itself. 3 is also has a factor pair of 2 times 3. 2 times 3 would also get me to 6. 27 is not divisible by 2, but it is divisible by 3, 3 and 9, and that's actually, those are the only factor pairs for 27. Looking at the ones they have in common, they both have 1s, and they both have 3s. So the GCF here is 3. 8 and 16, we'll go ahead and do the same process. 8 and 1, and 2 and 4, that's it for 8. 16, we have 16 and 1, we have 2 and 8, and we have 4 and 4 for 16. They both have 8s, they both have 2s, they both have 1s, they both have 4s. So every factor of 8 is actually also a factor of 16. But the greatest one that they share, the greatest one they have in common is 8. So once again, that is the largest number that both sides could be divided by. And once again, we've looked at the GCF a number of times throughout the school year. Oftentimes we would do it when we were simplifying fractions. So let's say you had the fraction 8 over 16, and we wanted to simplify it. Well, we know that the GCF is 8. So then we would divide both sides by 8. And 8 divided by 8 is 1, and 16 divided by 8 is 2. So we use GCFs often to simplify fractions because fractions kind of function like ratios. If you divide both sides of a fraction by the same number, you'll get an equivalent fraction. And if you divide both sides by the GCF, you will get the fraction in its most simplified form. So 8/16 and 1/2 are totally equivalent. Both would represent 5/10 or 50% of a number. All right. And then for the final one, 36 and 3, I'm not going to go through this whole process. I will just say that the GCF is 3. 3 is divisible by 3. It can't be anything bigger because that's itself. And 36 is also divisible by 3. All right, so now Kiera has 9 baseballs and 6 basketballs. If she wants to divide them into identical groups without any balls left over, what is the greatest number of groups Kiera can make? So this is a GCF problem because we are looking for, we want to split them up into the greatest number of groups. When we work with the GCF, we are looking for numbers that something can be divided by. If we look at 9, we have 9 and 1, and 3 and 3. If we look at 6, we have 6 and 1, and we have 3 and 2. The largest number that they have in common is 3. So Kiera can make 3 groups of 3 baseballs. She split up the 9 baseballs into 3 groups. It would be 3 groups of 3, and if she split the basketballs into those 3 groups, each group would get 2. All right, now for the LCM, or least common multiple. So the LCM is kind of like the opposite of the GCF. So you see the word multiple, so you know that we're talking about multiplying here. And you see least, okay? So that is the smallest multiple that 2 numbers can multiply to. So for instance, if we look at 4 and 6, we're going to go ahead and write a list. So 4, we'd have 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. I'm going to stop right there. So once again, that's 4 times 1, 4 times 2, 4 times 3. And then for 6, we'll do the same thing. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18. And what is the first number that they can both multiply to? 12. What is the LCM of 7 and 14? If I was multiplying these numbers, where is the first place they would meet? 7 times 1, 7 times 2, 7 times 3, 14 times 1, 14 times 2, 14 times 3. And they actually would meet right off the get-go. Because 14 is a multiple of 7. So then, the least common multiple, the first place they'd meet is 14. 14 times 1 and 7 times 2, both are 14. And the LCM of 9 and 15. Nine times 1, 2, 3, 4, and then 9 times 5. 15 times 1, 15 times 2, 15 times 3. So, the first multiple that they both have is 45. I can multiply 9 times something to get 45, and I can multiply 15 times something to get 45. So that is the least common multiple, the first multiple where they meet. Walter is keeping an equal number of square and rectangular boxes in a local storage facility. He stores square boxes in stacks of 9. So we've got the square boxes, and then he's got the rectangular boxes in stacks of 6. So what is the smallest number of each type of box that Walter can have? So they've got to be equal, and they come in stacks of either 9 or 6. So let's see. 9, 18, 27, 36. The rectangulars come in stacks of 6. So here's 1 stack, 2 stack, 3, 4, 5, and 6. So if they squares come in stacks of 9, rectangulars come in stacks of 6, but they're equal, then the least amount he could have is 36. All right, and that's it for your review. So remember, tomorrow is your final assessment for the year. So make sure that you are really reviewing your stuff tonight, going on IXL if you need to. And good luck, y'all.